The Bible says it rained 40 days and 40 nights. The Bible says the waters of the great deep broke forth, and the waters rose for some 5 months. Then they started to decline, and after 1 year and 17 days, Noah could leave the ark. Now that is decried a fairy tale today. A very strange little story, an allegorism, just to keep people happy. And makes a nice children's story. But in any case, that's what the Bible teaches. And that it took 1 year, 17 days, high in the mountains of Ararat, for Noah to actually leave the ark. You see, it says he was so old when he entered, he was so old when this happened, he was so old when he sent out the ravens and the doves, and he was so old when he left the ark. So you can work it out, how long it was. And it's 1 year, 17 days, with major activities happening during this event. And what's also very interesting is that if you look at the geological column, what you see is a lot of mud. And mud happens in what? Happens in water. So if you go to the Grand Canyon, for example, and you look at the various layers, then yes, what you see is one layer on top of the other. Now remember what science teaches. That was once the surface of the earth, followed by that one, followed by that one, followed by the next one, etc., all the way along. When you look at those layers, can you see that they're all nice and flat, and that the contacts between them are perfectly flat? You see that? Absolutely flat. It's like the world was and then came another world time period and went then came another world time period and everything very flat. Huge flat layers, one on top of the other. So there you can see them very nicely. 1, 2, 3, 4, 5, etc. They're all nice and flat. And the contacts between them are very flat. Now remember what science teaches. Each one of them was what? Once the surface of the earth. Okay, let's go down into the Grand Canyon. And you'll come to something which they've called an unconformity. This is what the geologists have placed there. And an unconformity is a very interesting thing. Here is where it is, they say. What is an unconformity? Well, I've told you before, nowhere do you find the whole column in one place. So some places there are pieces missing. And here's one of those. So here are 2 ages, but a rock layer that should be there here in the Grand Canyon is absent. Now, there are 2 possibilities. The mud is missing, or 2, the time is missing. Are you with me? Now, if you say the time is missing, then they'll say, whoa, here's the problem. Time just doesn't go away. So obviously the time must have been there. So science teaches, this is what happened. Well, obviously what happened here is the layers formed, and because time is an essence, the missing layers must have formed, because that time was there, and then there must have been some rapid erosion here, and they were rubbed out, away with them, and another layer deposited on top, and voila, we have 2 layers with a piece in the middle missing. No patty between the 2 burger rolls. Nothing. Just gone. Now, that's fascinating. That's what science teaches. What took it away? What's the only thing that took it away? Erosion. Right, let's have a look at them. Here they are. There's a time period missing in the Grand Canyon, and that is estimated to be some 100 million years gone. Here's another layer missing, some 30 million years gone. Now let me just put that in perspective for you. If we take the present erosion rates on this planet, and we measure how much of the soil is being washed into the oceans every single day. Well, you live here next to the Mississippi River. Is the Mississippi spanking crystal clear, yes or no? No. Why not? Because it's obviously taking material down into the sea, right? That's whatever it erodes away and it ends up in the ocean. So that's where it gets to end up. Now, the same must have happened here. There must have been a period of erosion, they say, and that took away the layer. Now, how much could be taken away in 100 million years? Well, did you know that at the present rate of erosions, if we take the lowest level for the United States, which is about 6 centimeters of Earth's surface every 1,000 years, the highest being in the Himalayas, some 2 meters gone every 1,000 years, then it would take just 10.2 million years to wash away the entire continent into the ocean using the lowest level. So 100 million years, that's enough to wash the entire continents, present continents, into the oceans at least 9 times over. That's quite extraordinary. Okay, here you have these flat layers with these contacts missing in between. 12 million years missing between those layers over there. 12 million years. That's enough to wash the entire continent into the ocean once over. And it's a huge area stretching over all of that, and between the 2 layers, this one and the one underneath it, just nothing, gone. Although we have evidence of a lot of water rushing, that should have left some erosion. Look at these contacts, flat, time missing, absolutely flat. Here you have 20 million years missing between this light one and this dark one. 20 million years gone, flat. What happened? Now, if you have erosion, isn't this what happens? Yes or no? Doesn't erosion make valleys and ravines and things like that? Here are 3 layers taken in Africa, on one of the mountain ranges there, the Cedarburg, very beautiful area. And look at them. There's one layer, there's another layer, and there's another layer on top. Let me give you another picture. There, on the left. Look at them carefully. A layer at the bottom. Now remember, what does science teach? This was once the surface of the Earth. There's the contact between them. There's the next one. There's the contact between them. Now, millions of years later, there's the next one. That's now on top. So that's getting some erosion exposure. Can you see how nice and flat it is? Is it flat, yes or no? No. It looks like this, up, down, down, whatever. Why? Because erosion washes it out like that. So now if I put another layer on top, let's say all this went under the ocean and I put another layer on top, would the contact be, or would it be, what would it be? What do you say? It certainly wouldn't look like that. So, do you think it's possible that that was never really the surface of the Earth for a very long period of time? And that before you could say, Jack Robinson, the next layer was on top? Is it possible? But what would that do to the evolution theory? What would it do? It would create a great problem, because these things happened over millions and millions of years with the same principles applying today, applying to the past. There will be a problem. Look at this. Here's a layer, 1, 2, 3. Everything in between is gone. Where is it? Well, it's been eroded away, obviously. All right, so if I put new layers on top, I certainly shouldn't get flat contacts, shouldn't look like that. Erosion will have it look like that, right or wrong? And if I put a layer on top, it should look like that, right or wrong? But it doesn't, it looks like this. All right, now let's think about this. Let's say this is the Grand Canyon, and the black is one layer, and the red is another layer, but I know there should be a yellow because it was found in another area. But it's not there in the Grand Canyon. So what does science teach? It was washed away by erosion. Is that right? And therefore, millions of years of time cannot be found there. But the contact is absolutely flat, and it shouldn't. It should look like that. So now, here's another.